Good morning, class. So far, we have learned about Ohm's law, resistance. Okay. So now in this class we are going to learn about resistivity. We have already learned about resistance. Now resistivity. So before resistivity, we should know the SI unit of resistance. Okay. SI unit of resistance. Okay. So what is the SI unit? The SI unit of resistance is ohm. We know V is equal to IR. Therefore, R is equal to V by I. This is a relation from Ohm's law to calculate the value of resistance. And what is the unit of resistance? R is equal to volt means voltage, current means ampere. So voltage per ampere is equal to ohm. So SI unit of resistance is ohm and symbol is ohm. Okay. This is the symbol of resistance we will use in this chapter. Okay. So now next is resistivity. Now class, we have already learned the factors on which resistance depends. Okay. So number one is resistance depends on temperature. Number two, it depends on length of the wire. Okay. Number three, resistance inversely depends on depends on area. Okay, got it? So resistance depends on temperature. As we know, if temperature increases for a metallic conductor, then resistance decreases. Okay, we have already performed an activity to justify this factor, this statement. Okay. Now next, resistance depends on length. Length is, if the length increases, then resistance also increases. Okay, we have already done. R inversely depends on area. If area increases, then resistance decreases. Now combining these two factors, we can define, or we have R is directly proportional to length. This is length. Okay. Again we can write R is inversely proportional to area. Got it? This area is the area of cross section of the conductor, or we can say wire. Now combine these two. Let this temperature. Okay, no need of writing temperature. This implies that R is directly proportional to L by area. Okay, you can write this. Now this is a proportionality sign. We will change this to equal to. Okay, R will be equal to, and there comes a constant, that is rho, L by E. This is the formula of resistance. Okay, where rho is rho, where rho is a proportionality constant, called as resistivity of the material. Okay, got it? So what is rho? rho is the resistivity of the material, and from where we are getting rho? From the formulation of resistance. Okay, so this R is equal to rho L by A, means R is directly proportional to L, inversely proportional to area. If length increases, resistance will increase. If A increases, resistance will decrease. Okay, and here comes a constant. This constant is called resistance or resistivity of the material. So we will learn about resistivity. Okay. Now we are going to study resistivity. So let us consider a wire. Let us consider a wire. We are considering a wire. Okay, this is a wire, and we know that if this is a wire, means this is a conductor and it has resistance. Okay, no doubt it will have a very less amount of resistance, but it will always have a value of resistance. Okay, so now do one thing, cut this wire into equal parts. Okay, say for example the length of this part is 5 meter. Length of this wire is 5 meter. Now cut it into 5 pieces of equal dimension. Okay, so 1, 2, 3, 4, 5. Now what is the value of 1 unit? This is equal to 1 meter. This is also 1 meter. This is also 1 meter. 1 meter. 1 meter. Combining all, we get 5 meter. Okay. Now you do one thing. You also cut the area into smaller parts. Say for example, if the area is given 4 meter square. Okay. Now cut the area into 4 equal parts. Okay. So if you cut, you just consider a small part, then you will get like this. Okay. Means this is a small part of this wire, and the dimension of this small part is 1 meter length and 1 meter square is the area. Now see, this is the smallest part, or we can think this is the building block of this wire. Just we can assume that. Okay. Now see, now you do one thing, you measure the resistance using a device. You measure the resistance of this small part R. So this R is equal to resistance of this small part of the wire. Now if you measure the small resistance of this small part, you will get a value of resistance. That resistance is actually resistivity. Okay, so this resistivity is the resistance of the small part of a wire or a conductor whose length is 1 meter and whose area is 1 meter square, or whose dimension is 1 unit. Okay, in SI unit. So we can write, or we can have resistance, and the relation between resistance and resistivity is this resistivity is the resistance of a small element. Okay, so this small resistance they together combine to form a whole resistance of the material. Okay, or we can say resistivity is the building block of resistance. Say for example, in a building, bricks are considered as the fundamental block or fundamental unit of the building, or they are the fundamental unit for construction of building. Okay, so now resistivity is defined as it is the resistance of a wire whose length is 1 meter and area is 1 meter square. Okay, this is SI unit. Okay, sometimes We can also define resistivity as it is the resistance of wire whose length is 1 centimeter and 1 meter square, 1 centimeter square. Okay, so this is the definition and the concept of resistivity. So what is the unit of resistivity? We have R is resistance is equal to rho L by area. Okay, now rho is equal to, transpose this part to this side, R A by length. Okay, so what is the unit of resistivity? What will be the unit of resistivity? R means ohm, area means meter square, length means meter. So 1 meter square cancel. So we will have unit of resistivity equals to ohm meter. Okay, this is the resistivity. And what is the inverse of resistivity in case of science? Inverse of resistivity means it is the power of the material to resist, just equivalent to resistance. Okay, means almost resistance and resistivity they are same. So inverse of resistivity will be conductivity. Inverse of resistivity. Inverse of resistivity is conductivity. Conductivity is the ability of the material to allow the movement of charge. Okay, how they allow the charge to move, that is called conductivity. How they conduct electricity. Okay, so inverse of resistivity is conductivity in case of lens. Okay, so now this is the unit of resistivity, ohm meter. Ohm meter is the unit of resistivity, ohm meter. Okay, note it down. Ohm meter is the unit of resistivity, and on which factor resistivity depends. So now factors on which resistivity depends. Resistivity depends on which factor depends. This resistivity depends on nature of the material. Number one, nature of the material. How? Say for example, rho Fe. This is the resistivity of iron. Rho Cu. This is the resistivity of copper. We know that copper's conductivity is more than conductivity of iron. Means copper is a good conductor than iron. Iron resistance. So if copper is good conductor means resistance is low. If iron is bad conductor means not bad conductor, it is actually poor conductor of electricity. So if iron is poor conductor of electricity means its resistance will be high. So automatically resistivity of iron is greater than resistivity of copper. Okay, so iron and copper, they are different materials. So resistivity depends upon nature of the material. Okay, so next, number 2, it depends on temperature also. Resistivity depends on temperature. Okay, how? Say this Fe is the resistivity of iron at say 24 degrees Celsius. Now you increase the temperature. Okay, you will find that resistivity of iron at say for example 100 degrees Celsius is greater than resistivity of iron at 24 degrees Celsius. Okay, so this resistivity depends on temperature. As we increase the temperature, the resistance increases, automatically resistivity also increases. But it is same for same material at constant temperatures. Same for example, iron, resistivity of iron at 20 degrees Celsius is same, and you take another equivalence of iron, its resistivity will also be same. Okay. Now say class, in question In this question, a current of 0.5 ampere flows through the filament of a bulb. We have a bulb, and inside the bulb there is a filament. So this much amount of current is flowing when connected to a power supply of 240 volt. 240 volt is the main power supply. Find the resistance of the filament. Then what is the resistance of filament? So before writing the before doing calculation, we have to write given. Okay, so here what is given? Current. So write I is equal to 0.5 ampere. What is next given? Voltage. So write the voltage is equal to V is equal to 240 volt. Everything is in SI units, so no need to convert it into SI units. So now what is required to find? Resistance. Okay, so how you will find resistance? From Ohm's law. From Ohm's law we have V is equal to IR. So V equals to, what is the value of I? I is 0.5 ampere. Into resistance. So what is the value of V? Given 240. So this implies that 240 volt is equal to 0.5 ampere into resistance. So transpose this to this side. So resistance will be equal to 240 divided by 0.5. So what is the unit of resistance? Ohm. So write down ohm. Omega. Now solve this. 240 into 10 for this 0.5, for this 1 point, 5 on 10 on numerator, 5 points are, okay, 5, 4 are 20, okay, 440, 5 8 are 40, 480 ohm, okay, got it? This is the value of resistance of the filament. This is a question you have to do by yourself. The coil of an electric heater draws a current of 8 ampere from a main power supply of 240 volt. Calculate the resistance of the heater coil. You have to calculate the resistance of the heater coil. Power supply is given, current is given. Use the concept of Ohm's law and find the value of resistance. Okay, and send the calculation to my WhatsApp number. You have to send the short answer to my WhatsApp number. Okay, thank you.